Okay, so today we're going to be talking about this little thing called expanding. What does it mean to expand something? Make it bigger? Yeah? So when I say expand, we're going to start with one log, and we're going to make more logs. Start with one log, pretty ugly log, and we're going to make more logs. Okay? After expanding, what we're going to do tomorrow is called condensing. It's the opposite of expanding. What does it mean to condense? Make smaller. So I'm going to take something that has lots of logs and bring it down to one log. Okay? Now, the worksheet that we just did, this guy right here, I have these three rules that I came up with. Number 3, number 5, and number 7. Those are the most important parts of this worksheet. Okay? We learned that if you are adding two logs that have the same base, that is the same thing as multiplying the two numbers and keeping it in one log. One of these is the expanded form. The other one is the condensed form. Expanded has more than one log. Condensed has only one. Our second rule said that if you are subtracting two logs, that you end up dividing them. And this is the expanded side. This is the condensed side. Get the idea? Down here, it's a little tricky because they're both single logs, but this would be your expanded side. This would be your condensed side. So mathematically, how would you see that in a book? You would see it like this. Okay? Unfortunately, this is backwards of how we had it there, but the expanded side is right here. The expanded side is right there. And the expanded side is right there. So we are going to take things that look like this, and we are going to use our three rules here to expand them to look like this. Does that kind of make sense to you as far as what we're going to be doing? Okay, let me get a good color to write with. Okay, so let's see. Remember these rules. We have some things. Log base b of b equals 1. When your base and this number match, it equals 1. That's because if you were to change this to exponential form, it would have to be 1. Log base b of b to the x, and we'll talk more about these rules later, is x. Log base b of 1. Anytime this number is 1, the result is 0. And sometimes you may need to change a radical to a fractional exponent in order to expand a logarithm. Okay? All right, so starting with the first one. What rule do you think I'm going to be using? Am I going to be using the product rule, the quotient rule, or the power rule? Quotient rule, because I've got a quotient going on, yeah? So how can I expand a quotient? I can expand it to the log of the top minus the log of the bottom. Keeping note that what happens to the bases? They stay the same. Whatever it is in the problem, that's what it's got to be throughout. So this would be expanded to become log base 7 of 7 minus log base 7 of y. Keeping the base the same, I have the log of the top minus the log of the bottom. Pretty simple, right? Not quite done here, though. Anytime I have a log of a number, not a letter, I have to remember what is log base 7 of 7. From what we did the other day, log base 7 of 7, I can actually solve that. Whenever I have numbers going on, I always have to check if I can solve. So log base 7 of 7, if I said equals y, for example, I should probably use x, but that's okay, I already used y. What would this become? 7 to the y power equals 7. What does y equal? 1. So this whole log equals 1. So actually I need to replace that with 1. And then I have this guy. Because this one isn't a number, it's a y, I can't do anything with that. Does that kind of make sense? A little bit. Okay, let's keep going. What rule do you think I have going on here? I'm looking mostly right here. Do you think I have the product property, the quotient property, or the power property? Product property, right? I have 10 times x times y. Well, what is times, or multiplication, going to expand to? Addition. So I can call this log base 3 of 10 plus log base 3 of x plus log base 3 of y. What I want to get down to is I want to get down to each log having only one thing going on with its number. I don't want any multiplication or division or exponent or anything going on with that. I want each number or each letter to have its own log with it. Now, two of these are all are letters, x and y. I can't do anything with that. This one I have to look at like I looked at the last one. Can I change this into something nice? In other words, if I set that equal to y, does 3 to the y power equal 10 give me a nice result? It doesn't, does it? Because it'd be 3 to the, what, 2 point something? Yeah, because 3 squared is 9, 3 to the 4. It's not going to be a nice number. So if I can't turn this into a nice number like I could over here, then I just leave it. We don't really want to be dealing with any decimals or anything here. Okay? So anything that's made up of numbers, check it. But if it doesn't turn into something nice, then don't change it. Okay? Let's look at this guy. None of my rules deal with radicals. My radical, however, can be written as a fractional exponent, and I do have a rule that deals with exponents. So what would this be written as if I wrote it in exponent form? It would be log base b of what? 5 to the 2/3 power. Now I probably should have checked before I did this, but I can't take the cube root of 5 and square it, right? It's not nice. Not a pretty number. Or 5 squared, which is 25. I can't take the cube root of that nicely. If I could have simplified that, I should have checked that beforehand, but I didn't. So now, which rule am I going to use? The power property. So what does this power property say? It says that if I have an exponent, what do I do with that exponent? I bump it to the front. So I'm going to bump that 2/3 to the front, and I have 2/3 log base b of 5. That is the expanded form of that logarithm. So? Okay. So each one of these use the properties individually, one at a time. Now, we're going to use them all together. If I look here, I have all three properties going on. I have multiplication going up on the top. Do you see that? P to the 4th times Q to the 5th. I have exponents galore. Everything has exponents. And I have division because I have a fraction bar. Where do I start? Well, the easiest place to start, get rid of the fraction. So which one deals with the fraction? The quotient. And that tells me that division becomes subtraction. So I'm going to separate it and say that the log with the same base of the top, which is P to the 4th, Q to the 5th, minus the log of the bottom is the first step in our expansion here. I've gotten rid of the fraction. Are you sort of okay with that? Okay. Now I got to break up some more stuff. Any of these include multiplication that I can break up to addition? P times Q, right? So I got to break that up into addition. So that would become log base 4 of P to the 4th plus log base 4 of Q to the 5th. And then I still have this minus log base 4 of R to the 1/2. Do any of my logs involve more than one letter or number? Not including exponents. I have got one thing going on there, one thing going on there, one thing going on there. So I don't have to worry about any more addition and subtraction expanding. But I got a lot of exponents to deal with. What do I do with the exponents to expand them? Bump them to the front, right? So each one of these has to have that exponent bumped to the front of that term. So I have 4 log base 4 of p plus 5 log base 4 of q minus 1/2 log base 4 of r. Do I have any multiplication going on after the word log? Nope. No multiplication, no division, and no exponents. They've all been dealt with. That is the fully expanded form of this guy right here. By the way, why are we expanding things? Because we're going to end up solving equations, and this helps us solve equations. Same with condensing that we'll do tomorrow. Okay. Next one. Now, some people look at the next one, they go, oh, shoot, that's a really messy base. You see that base? It's not pretty, is it? I mean, x plus 2 by itself isn't intimidating, but when you put that as the base of a log, not really something I want to deal with. Does the base affect any of my rules? No. It just carries on through it. So even though the base is intimidating, we're not doing anything with it other than rewriting it over and over again as we expand. So don't freak out because of the base. Now, there is something different about this one, however. Let me zoom in a little bit. There is something different than there was about the previous one. Other than the fact that I'm using different letters and a different base, does anyone know or notice what could be different on this one? What was that? B doesn't have an exponent. Yes, that is different. That's not the one I'm looking for, but that is true. The base has addition. That is different. Anything else?
The BC, there's no exponent for the B.
Uh-huh.
So wouldn't it be 1 minus something?
Not necessarily. Okay. Let's break it up first. What did I say was the best thing to break up first? Get rid of the fraction. So let's do the log of the top minus the log of the bottom. So log base x plus 2 of a to the 1/5 minus log base x plus 2 of b, c to the 4th. That's my first step. What else needs to be broken up now? The b and the c. Now here's where it's different. This is what I was looking for here. In my first step here, the multiplication that I had to break up first. Yeah? Now it has to break up second. I'm breaking up something that comes after a minus sign. That kind of makes a difference. What I have to do is this first term stays the same. I'm not going to deal with it yet. Yes, I know I'm going to have to bump that exponent out to the front, but I'll do that later. But if I have a minus sign, and it really only matters with a minus sign, a plus sign, it doesn't make a difference. But if I have to break up more stuff after a minus sign, I have to put it in parentheses. Because I'm going to have to distribute that minus sign to everything that breaks up after it. So, I opened up a parentheses, so I can now break this up. Log base x plus 2 of b plus log base x plus 2 of c to the 4th. And because I put those parentheses there, what do I have to do with that minus sign? Distribute. Now, why did I say it doesn't really matter if it's after a plus sign? Because distributing a plus sign doesn't change anything. Distributing a minus sign does. So, I now have minus log base x plus 2 of b, and then not plus, but minus log base x plus 2 of c to the fourth. People that don't understand this example or don't understand this process of breaking something up after a minus sign end up putting a plus there because they didn't distribute that minus sign. My last step is what? Bump those exponents out to the front. Always take care of division first. Well, I shouldn't say always. Usually you will take care of division first. But regardless, take care of division and multiplication first, if you can, and save the exponent for last if you can. All right? So I finally end up with 1/5 log base x plus 2 of a minus log base x plus 2 of b minus 4 log base x plus 2 of c. Kind of sort of getting the hang of it? Kind of sort of? Okay. This last example, do you notice these two are actually the exact same problem? I'm going to show you two different ways that you could do the same problem. Both ways will get you to the same answer. Okay? Now, the first way that I'm going to think about is I've got some messiness going on right here. If I ignore the fact that it's a log, this has some messiness that can be simplified, right? I could call this 2 cubed, and then a to the what? 2 times 3 is 6, and then b to the third. I could do that, couldn't I? And then that, to me, if I put the log base 2 of that, is fairly easy to break up. Yeah? This is all multiplication, so how could I break it up? Break it all up to adding, right? Because multiplication breaks up to adding. So what could I call this? I could call this log base 2 of 2 cubed plus log base 2 of a to the 6th plus log base 2 of b to the 3rd. You doing okay so far? And then I could bump all those exponents to the front. And that gives me 3 log base 2 of 2 plus 6 log base 2 of a plus 3 log base 2 of b. Now, I do have a problem because one of these has all numbers with it. Which one has all numbers? The first one. We haven't had to deal with that in a couple problems because we've had letters. But what is log base 2 of 2? 1. Anytime these two numbers match, it's 1. So I really have 3 times 1 because this whole thing is just 1. Plus 6 log base 2 of a plus 3 log base 2 of b. So what do you think my final answer looks like? 3 times 1 is 3 plus 6 log base 2 of a plus 3 log base 2 of b. And that's my most simplified form. So far, so good? Now, what if I did not deal with that exponent first? What if I did not distribute things? Now, this is my preferred way of doing it because I think it's a little bit easier. But I am going to show you another way if you didn't do that. Because this is all in parentheses, I can't expand it until I deal with this exponent. So what if I bumped that exponent out in front first? And I said that this was 3 times log base 2 of 2a squared b. Now what? I got these guys, I can break them up, right? But since there's an exponent and I'm breaking up something after, it's very much like this subtraction problem where everything that I break up after that has to be applied to it. So I can say that this is log base 2 of 2 plus log base 2 of a squared plus log base 2 of b. And I can even go one step further of saying that log base 2 of 2 is equal to 1 plus, let's see, I can go distribute these guys in the front. 2 log base 2 of a, and no exponent there, so just log base 2 of b. And now I have to distribute that 3. So 3 times 1 is 3. 3 times, what do I multiply it by there? The 2 or the a? The 2. So that gives me 6 log base 2 of a. And over here I also multiply it by the coefficient. So that would be 3 log base 2 of b. That's the exact same answer as I got over here, right? Yeah. So it doesn't matter which way I go as long as I remember to follow the rules. And again, if I pull a exponent out to the front and I still have more breaking up to do, I'm going to have to distribute that exponent back in at another time. Okay? Kind of sort of get it? Okay. So let me pass out your homework for you to get going on.